All the same sensors and hardware. It's just a static demonstration. So if you start up here, we have 20 sensors. Sensors are.
Yeah.
There's vision, radars, and lidars.
Okay.
And the radars, we have short range and long range radars. All the radars are 77 gigahertz, so it's a worldwide frequency band. So the radars are all production sensors for us today. We have 6 long range radars. They're mounted behind the fascia, 2 point that way, 1 point straight to the front. Right?
Okay.
Again, they're behind the plastic.
Are these them?
Those are lidars.
Okay.
Right. We have with each long-range radar, we also have a lidar.
Okay.
Scanning lidar. It's used for sensor redundancy. Right.
I see.
With ADAS, you can get by with a minimal sensor set, but when you turn operation over to the vehicle, complete operation, then you need some redundancy for functional safety.
I see.
Right. So we have, in many cases, our sensor fields of view overlap. Right. The information we use it comes from multiple sensors. Right. And then we fuse that information together with the confidence levels, to make the right decision. So again, there's a lidar, radar, long range. There's a lidar, radar, long range radar, and then in each corner we also have short range radars. Again, for that short range, 360 degree cocoon. So,
I see.
So the long range radars have there are standard ACC type radars. Okay. So it's a multi-mode. It has a 90 degree field of view out to about 60 meters, and then a 15 degree field of view out to 200 meters. Protection. So in this case, we have them pointed to the side because when we do our urban driving, we have intersection control that we have to make sure that no one's coming, even running the red light, right? So
I'm sorry. So there's our 3 short radars and 3 long radars.
There's 3 long range radars, 3 long range lidars in the front. And then there's 2 short-range radars.
2 short, okay.
The short-range have a wider field of view. So they're actually 160-degree field of view. So when you put one in each corner, it covers the full 360.
Okay.
Now there's a small gap where it can't see, right? Immediately, in the middle of each side. But
hopefully it's detected before it gets to that position.
Yeah, and then we can track it through there.
Yeah.
Right? So. Now, in addition to the radars and the lidars, we have 3 cameras on the car.
Are those the ones that are mounted up there in the windshield?
There's actually 2 in the windshield. We have our standard ADAS camera, which is in the middle here, and that uses the Mobileye algorithms, right, for lane detection.
What kind of algorithm? I'm sorry.
Mobileye vision algorithms.
Yeah, okay.
Right. So again, that's our standard ADAS. So it has lane detection, pedestrian detection, vehicle detection, traffic signal, or not traffic sign detection. Right. But it cannot do the black and white wide VGA camera cannot do tell the colors of the traffic signals. Right. So we've added a megapixel color camera.
Nice.
Just for that. Right.
Oh,
now,
just for the signals.
We will merge that, right, eventually to a single camera that can do traffic signals as well. But again, for highway driving, highway pilot, those automated features like traffic jam assist, you don't need traffic signal detection, right? But for urban driving, right, you do need the traffic signal.
Sorry, does it work better at night and versus daylight versus nighttime?
The traffic signal?
Yeah.
Well, it's better at night. Right, there's more contrast.
Right?
Yeah.
Okay.
So, but we've been able to handle the arrow signals here on your drive. You'll see there's several left turn arrows, right? So it can see, that's a difficult situation, right? Especially. About this time of day, right, the sun angle on a couple of the lights is terrible, right? But it seems to be able to robustly handle that. Right? So But again, we do need that separate camera in order to do that type of detection. So. Let's see. Lastly, we have a thermal imager.
Nice.
Far infrared camera. Now that's not integrated into our system today. It's for future development of long-range pedestrian detection, especially at night.
So long range.
Yeah, long range at night. So.
Avoid the deer.
And the deer.
Yeah.
Livestock.
So we'll walk around the back. And it's a neat installation. There's not racks of
No computers.
and big fans and
No
everything
server
else,
in here,
right? So see, we have the lidar and the radar pointing straight back. We have short-range sensors again in the corners, and these are our standard blind spot short-range radars, right? They've been in production for 4 or 5 years now, right? Again, our short-range radars are 77 gigahertz. So
Where are your computers hidden?
what's that? Oh, we can't tell you.
Okay.
Yeah. Trade secret.
Trade secret? Okay.
Of course we have them, but they're integrated and they're kind of packed in, right? So.
Oh, okay.
But
Very
the
nice
idea
and neat.
is that we don't have a big spinning washing machine on top. We don't have racks of equipment, right? The early generations of autonomous
one out
vehicles,
there,
like the
yeah.
one out there, had to have that, right? We are now more sophisticated, not only with our integration, but with our algorithms and our perception systems. So.
Yeah.
Let me see. How soon are you ready for the first two gentlemen from Hubble?
We were just talking, so we're gonna go ahead and start with these